Hey guys, I wanted to make a quick video that sort of acts as an answer key to investigation 8.1 and 8.4 assignment. I'm really just going to go over in this video 8.1c because that's the chi-square test. How do you do a chi-square test in heredity? You are going to do one of these on the heredity exam. So I started to go over this with both classes. I don't know how far I got through it, but in this video I will show you the actual answers. So the first chi-square to do is for seed shape. The second one is to do seed color. You do not have to do the other ones. So seed shape, I'm going to write my observed genotypes here. So on my paper here, this is for seed shape. I'm going to write dominant, recessive, and total, and we've got 5,474 dominant, we've got 1,850 recessive. That is a total of 7,324. So what do I want to do? Well, if I look through the information that's given here and I think it through and I follow it, I can figure out that this is basically when you allow the F1 generation here to self-pollinate, you're basically crossing a heterozygote with a heterozygote. So you're doing a cross that is like this, right? And you guys should know that in a hybrid cross like this, you are going to get a 3-to-1 dominant to recessive ratio. So I don't know exactly 3 dominant, 1 recessive, right? Out of 4. So I don't know exactly what the numbers are going to be, but I know I'm going to get a 3/4 of the offspring looking dominant, 1/4 of the offspring looking recessive. So as we discussed in class quickly, you could either divide the total in 4 parts, and you know 3 of those parts end up here and 1 ends up here, or you could say 7,324 times 0.75 for my 75%, and put that number here, and 7,324 times 25 times 0.25 to put 1/4 of that here. Those numbers, if you do that math, come out to be 5,493 and then 1,831. That equals my total here. I'm going to do observe. This is my observe. This is my expected. I expect a 3-to-1 ratio. So the next thing to do is observe minus expected. And if I do this math here, I subtract this from this, I'm going to get -19. And over here, I'm going to get +19. That's not weird. A lot of times these will come out with the same number there. And then observed minus expected squared over expected. You're going to have the formula sheet, but the formula sheet is just going to say what the chi-square formula is. It's not going to break down all these steps for you. So you're going to have to remember to do this. So this would be -19 times -19, which of course is going to be a positive number, divided by this. So that's 361 divided by this expected number from this column. This is going to be 361 divided by this expected number, right? This comes out to be 0.06 if you crunch those numbers, and this comes out to be 0.19. Then you know what you're supposed to do is you add up these values to get your final chi-square value, and so this is going to be a chi-square value of 0.25. Now, what do I do with this number? Now remember, you've got, and I will certainly let you use your formula sheet, but just to quickly go to our formula sheet on Classroom here, the easiest way to find the formula sheet is either like Google image it or go to reference, and actually it's at the top, AP Bio formula sheet, and there's our chi-square. This, remember, this is letting you know that you do observed minus expected squared over expected. That's your calculation, but this sign means sum. So that means you do, for each category, observed minus expected squared over expected, and then you get the sum of it. That's what that means. So hopefully this is now something that is very helpful for you. The degrees of freedom of this experiment is the number of categories minus 1. So that would be a degrees of freedom of 1 for this one, because all I've got is dominant and recessive. And so that is a critical value of 3.84. You will be told to use a p-value of 5 or 0.05. This is within 95% confidence. So the critical value is 3.84. We are way under that. So we are going to accept the null hypothesis. Now, we should have made the null hypothesis in this video first. Remember, it says this on the study guide. Now it does. I added it today. The null hypothesis in a chi-square investigation says my observed and my expected are the same, or any difference between them is due to chance. So I'm going to accept the null hypothesis. This is coming out as a 3-to-1 ratio, even though, my observed. This is coming out as a 3-to-1 ratio, even though it's not exactly what I expect. It's very, very close, and that is reflected in an extremely low chi-square value, a value that is far under the critical value from the degrees of freedom table here, or chi-square table. So that's how you do seed shape. Now, if you have not done seed color yet, please do seed color first and see if you can get it right. But this is my work for seed color here. And if I zoom out enough, I think you should be able to hopefully maybe pause the video or write this down real quick. And that should be my work, how your work looks for seed color. Now, there's one other thing I want to go over in this video. And it is, what if this was a 2-gene cross, right? What if I was told that there was a, let's say, I don't know, a dihybrid cross, and the values came out as, I'm going to totally make this up off the top of my head right now, but it came out to be showing both dominant traits, both dominant, I don't know, 2,321, and dominant for one and recessive for the other. There was, I don't know, 642. And then recessive for the first, dominant for the second was 598. And then recessive for both came out to be 120. All right, let's say these were my numbers. Is this what I expect from a dihybrid cross? This would be my observed values. Well, I would want to first total this up. I don't know what this is off the top of my head because I just made these numbers up, but I would get my total there. And then what would I do for expected? Think about it for a second. Well, you might remember that a dihybrid cross is supposed to be a 9-to-3 to 3-to-1 ratio, right? So how do I do that here with these numbers? Well, I'm going to take my total and I'm going to say, okay, 9 out of 16 boxes should be what I expect there. 3 out of 16 boxes, 3 out of 16 boxes, 1 out of 16 boxes. I can now convert these fractions to decimals, and I can multiply those decimals by my total and get my expected values. And then I'm off and running on my chi-square calculations. I do my observed minus expected squared over expected in each column. I add them all up and I get my final value. I think this might have been the part that you needed me to clue you into. That 9-to-3 to 3-to-1 means 9 out of 16 boxes, 3 out of 16, etc. If this was an expected 1-to-1 to 1-to-1 ratio, right? That would be dividing the total number in quarters and putting it evenly in the 4 categories, right? So I hope this video helps. I hope you're going to be okay doing a chi-square investigation on the test on Wednesday. Goodbye.